At first light, the tower looks less like a mountain than an object left behind. Its sides rise in long vertical grooves, as if something fibrous once ran through it. The summit is flat enough to hold soil and trees. Around the base sits a ring of broken stone that spreads outward like the remains of a collapsed outer shell. In photographs, the scale is wrong in a very specific way. It does not resemble a peak. It resembles a cut surface, a section, a stump, and once that comparison enters the frame, it becomes difficult to remove. The eye keeps finding the same shape in mesas, buttes, plugs, table mountains, and truncated ridges across the world. The land begins to look manufactured by a pattern it is not supposed to have. The official explanation arrives quickly, and on paper it is straightforward. Devil's Tower is usually described as an igneous intrusion, magma forced upward beneath older rock, then exposed after millions of years of erosion stripped the surrounding layers away. The columns are cooling fractures. The flat summit is simply what remained. Elsewhere, flat-top mountains are explained by caprock, resistant strata, volcanic necks, uplift, glacial planing, or differential erosion. The timeline stretches across deep time, and geology is comfortable there. Processes accumulate, layers rise and fall, water cuts, wind removes, ice grinds, heat fractures. Nothing in that account requires mystery. And yet the problem is not that the official explanation is false. The problem is that it often feels incomplete in the same place every time, at the level of form. Why do so many unrelated landforms resolve into the same silhouette? Why do so many isolated masses share the same abrupt verticality, the same flattened crown, the same radial debris, the same bark-like striation, the same impression of having been cut rather than merely worn down? Geology explains each case locally, but the eye is comparing them globally. The contradiction begins there. One mountain can be a volcanic remnant, two can be coincidence. A continent full of stump-like forms raises a different question. Not whether mountains are secretly trees, but why the resemblance is so persistent that entire communities now see it before they hear the science. There is a hidden theory here, and it deserves to be stated carefully. The serious possibility is not that every mountain is literally the fossilized base of a giant biological trunk. The material record does not support that leap. The serious possibility is that many of the landscapes we casually call mountains are not one thing at all, and that our broad categories have concealed a repeated physical pattern. Enormous vertical masses exposed in cross-section, stripped of their surroundings, crowned flat, ringed with collapse, and preserved so cleanly that the human mind reaches for the nearest familiar analogy. What changed was the explanation. The image remained. The pattern did not disappear. Start with the measurements, because scale has a way of clarifying instinct. Devil's Tower rises roughly 800 feet from its immediate base and more than 1,000 feet above the Belle Fourche River nearby. Its summit area is only a few acres. Its sides are not smooth slopes but bundled columns, many of them six-sided, standing almost vertical for hundreds of feet. At the foot of the formation lies a tailless apron of fallen blocks. None of this proves anything exotic, but it matters that the form is not random. It is organized. A flat top, a steep cylindrical body, long vertical segmentation, broken material gathered below. If a child drew a stump the size of a mountain, the outline would not be far off. The same visual grammar appears again and again in landforms that were supposedly produced by different sequences of rock, heat, and erosion. There are mesas whose caprock forms a broad crown over steep walls. There are buttes that stand alone like severed columns. There are volcanic necks with fluted sides. There are basalt plateaus trimmed into tables by retreating cliffs. There are isolated domes whose outer slopes peel away in slabs while the central mass remains dense and intact. The record shows a family resemblance even when the geologic explanations diverge. That matters because classification tends to separate what vision combines. One site is filed under intrusion, another under erosion remnant, another under sedimentary plateau, another under laccolithic uplift. The language fragments the pattern the eye keeps restoring. Old photographs sharpen the effect. 19th century survey images of the American West are filled with forms described as towers, monuments, castles, citadels, chimneys, needles, tablets. Surveyors did not call them stumps, but they repeatedly reached for architecture and truncation, again and again. The landscape was described as if something larger had once continued upward or outward and had been removed. This is not proof of a hidden civilization or a vanished forest of impossible scale. It is evidence of a recurring impression recorded before internet theories existed. The resemblance is older than the meme. The record is still there. The next layer is material analogy. Real wood can become stone. Petrified forests prove that without ambiguity. In those specimens, cellular structure survives while organic tissue is replaced by minerals, often silica. Grain remains, rings can remain, bark textures can remain. Entire trunks can harden into rock while preserving the memory of form. The stone remembers. That is precisely why the giant tree theory gained traction so quickly online. It did not emerge from nowhere. Actually, it emerged from a legitimate fact pushed far beyond the scale the evidence can bear. If wood can silicify, people ask, why not whole forests? If trunks can fossilize, why not mountains? But scale is not a detail here. It is the entire problem. A petrified log preserves microscopic biological structure. A mountain does not. The rock in most stump-like mountains does not contain wood anatomy, growth tissues, or the mineral replacement patterns expected of fossilized plant matter. The chemistry is wrong, the internal fabric is wrong, the fracture systems are wrong. Yet dismissing the theory at that point still leaves something unexplained in public terms, because the question that made it persuasive was never purely chemical. It was morphological. Why do the forms converge so tightly on a single familiar image? And the answer lies less in hidden botany than in repeated geologic processes that expose mass in ways our brains instinctively read as cut wood. Consider columnar jointing. When thick bodies of igneous rock cool, they can fracture into regular polygonal columns. The process is well studied. It can produce giant organ pipe structures, hexagonal faces, vertical fluting, and bundles of near-parallel stone that look improbably designed. In cross-section, these columns create surfaces that resemble grain. Along a cliff, they read like fibers. When erosion later strips away the softer material around them, what remains can resemble a giant core. That is a sober explanation. It is also, visually, a gift to every stump theory ever proposed. The official account explains the physics. It does not make the image less uncanny. But then there is caprock and differential erosion. A resistant upper layer can protect the summit while the softer strata below erode back or down, leaving flat-top mountains, mesas and buttes with abrupt edges. Over time, large plateaus shrink into tables, tables into buttes, buttes into isolated remnants. The process is patient, measurable, and ordinary by geologic standards, but what matters is the sequence of shapes it generates: broad crown, narrowing body, detached column, collapse at the base. The same outline appears at different sizes in different climates because the logic of erosion is recursive. A system does not need intention to repeat itself, it only needs rules. This is where the mainstream explanation deserves to be treated fairly. Modern geology can account for a great deal. And when it explains why some towers are igneous intrusions, why some flat-top mountains preserve ancient strata, why Tylus collects below cliffs, why columns fracture the way they do, why rivers isolate mesas, why glaciers plane summits, why uplift exposes buried bodies, why massive rock can look carved without ever being touched by a blade. None of that should be thrown aside for spectacle. But a fair reading of the mainstream view also shows its limit. It is extremely good at local genesis. It is not always interested in global resemblance. It answers what a formation is made of and how it formed. It is less concerned with why 1,000 separate explanations keep producing the same visual sentence. What if the hidden story is not that the science is wrong, but that the categories are too coarse? Mountain is a public word. Not a precise origin story. It covers folded ranges, volcanoes, batholithic domes, erosional remnants, uplifted blocks, dissected plateaus, monadnocks, plugs, laccoliths, and things in between. A map will often label them with one convenient term because administration prefers continuity over nuance. Tourism does the same, law does the same, education does the same. Once a landform enters the public record as a mountain, most people stop asking what kind. Bureaucracy smooths over morphology. It has to. But that convenience comes at a cost. What remains hidden is difference itself. That institutional flattening matters more than it sounds. In cadastral records, resource surveys, park boundaries, transportation plans, and feature registries, landscapes are often documented for ownership, access, extraction, or preservation. And not for philosophical clarity. The file needs a name, a class, a boundary, a jurisdiction. It does not need a meditation on why the same isolated mass keeps appearing in the same visual language from Wyoming to Namibia to Australia to Brazil. There is no dramatic conspiracy required. There is inertia. There are standardized forms. There are accepted categories that become difficult to revisit once they harden into practice. The truth can be obscured simply because no institution is rewarded for rearranging the vocabulary. Maps make the pattern wider. Look at drainage lines around isolated buttes and towers, and a familiar geometry appears. Runoff radiates outward from a resistant central mass, while surrounding softer surfaces retreat. Look at topographic contours, and many of these forms resolve into nested rings or abrupt platforms. Look at stratigraphic diagrams, and entire plateaus appear as surviving caps above removed surroundings. Look at aerial photography, and the resemblance intensifies. The stump is often not a mountain rising in the ordinary sense at all. It is a remnant left after a larger field has been taken away. Seen this way, the comparison becomes less absurd. A stump is not defined by wood, it is defined by subtraction. The pattern repeats on more than one scale. A quarry wall can show miniature columns beside a highway cut. A basalt flow can fracture into organ-like pipes just feet high. A mesa can preserve the same logic over miles. The geometry scales up and down. That is one reason the image feels so persuasive. Human perception is built to identify repeated form across size. We do it with rivers and veins, lightning and roots, our coastlines and lungs. Once the mind notices that an isolated mountain shares the same structural rhythm as a stump on a forest floor, it carries the analogy upward. The leap is intuitive. The mistake is taking intuition for identification. There is another reason the theory persists. Many of the world's most iconic landforms do not look like the gradual products the public has been taught to imagine. Children are shown rounded hills, snowy peaks, patient erosion, river valleys opening over ages. Then they encounter a tower with sheer sides and a flat crown, or a giant mesa severed from its plateau, or a wall of hexagonal basalt columns so regular it resembles poured metal. The picture and the lesson do not match. Into that gap rushes narrative. If the official explanation feels too slow or too general for the shape in front of the eye, a more vivid explanation takes hold, not because it is true, but because it fits the image more tightly. Mining and extraction deepen that suspicion. Across the industrial world, humans routinely remove surrounding material and leave isolated masses behind. Strip mines, quarries, terraced cuts, spoil rings, haul roads, and exposed seams have taught the modern eye what subtraction looks like from above. We know what it means to cut down to a resistant layer. We know what broken debris looks like around an exposed central body. We know the visual grammar of removal. So when people look at a butte ringed by talus or a plateau scalloped into retreat, they reach for the industrial analogy first. The landscape looks worked, even when it is not. What changed was not the land, it was the observer. Almost old landscape paintings and early photographs show that this tension is not new. Long before digital culture, artists exaggerated isolated formations because they sensed their strangeness. Photographers placed tiny human figures at the base of towers to force the scale into view. and the contrast made the formations look even less natural. Survey reports lingered on abruptness, solitude, vertical seams, detached crowns, broken skirts of stone. These are not the words of people discovering giant trees. They are the words of people confronting forms that seem to belong to a different category from the one available to them. The language bends, the image resists. Now widen the frame even further. Around the world there are tepuis with flat summits rising like tables above rainforest. There are volcanic plugs standing alone after softer material disappears. There are inselbergs, mesas, cuestas, buttes, necks, domes and monoliths whose local histories differ but whose silhouettes converge. Some preserve horizontal layers like stacked boards, some show columnar fracture like bundled fibers, some carry summit soils and vegetation that make them look as if new growth has taken root on an old cut. The details vary, the profile returns, the pattern does not disappear. This is why the most literal version of the giant tree idea misses the deeper point. It treats resemblance as identity, it sees a stump and demands wood. But the more unsettling interpretation is almost the opposite. These landforms are not hidden trees, they are evidence that our categories hide how often the earth exposes mass by removal, by collapse, by weathering along internal structure, by stripping down to resistant cores, by preserving crowns while undermining bodies. In other words, the landscape keeps manufacturing stump-like forms because the physics of fracture and erosion favor them. The hidden history is not biological, it is classificatory. We have been calling unlike things by one familiar name and then acting surprised when they look too similar to ignore. What about the obvious objection that not every mountain looks like this? Of course not. Folded ranges do not. Shield volcanoes often do not. Alpine peaks carved by ice often resolve into ridges, horns, cirques and arêtes, not stumps. The phrase "every mountain is a tree stump" collapses under its own weight the moment it leaves the meme and meets the map. But slogans are not useful because they are accurate. They are useful because they force a closer look. In this case, the closer look reveals something real. A large share of the most visually arresting isolated mountains are not representative mountains at all. They are remnants, plugs, tables, columns and exposed cores that public language has blurred together. And once you recognize that, other oddities begin to make sense. Why do so many of these formations attract sacred narratives? Lost world legends, giant stories, forbidden zone myths and origin tales? Because abrupt, isolated masses do not behave like background terrain. They dominate horizon, weather, route and memory. People preserve stories around them precisely because they feel singular. Institutional language later files them into neutral categories. The sacred tower becomes a feature class. The unexplained mesa becomes a scenic overlook. The monument becomes a textbook example. Something is gained in that translation, but something is also stripped away. Not truth, exactly. Texture. Context. The feeling that the shape itself is asking for another question. That question is not whether geology works, it does. The question is whether explanation has become too compartmentalized to address what ordinary observers are actually seeing. When a person says a mountain looks like a stump, they are usually not submitting a mineral assay. They are registering a form. If the only response they receive is that erosion happened over millions of years, the answer can be correct and still feel evasive. Because it skips the visual fact that triggered the comparison. It leaves the image untouched. And images are stubborn. They survive instruction, they survive correction. They keep returning until language meets them where they are. There is a final reason the theory lingers at the edge of respectability. It flatters a broader intuition many people already carry, that history is full of renaming. Old buildings become impossible to classify. Buried infrastructure is rediscovered under modern streets. Forgotten industrial sites are mistaken for ancient ruins. Administrative language hides former uses. Archives preserve contradictions no one revisits. Once that pattern is familiar, it becomes easier to suspect that landscapes have been renamed in the same way. A stump becomes a butte. A remnant becomes a mountain. A strange thing becomes an ordinary one simply because the file drawer needs a label. Again, no grand plot is necessary. Our bureaucracy is often enough. But the strongest version of the argument remains the simplest. Put the photographs side by side, compare the profiles, compare the flat crowns, vertical segmentation, radial debris, isolated placement, and exposed central mass. Then compare the explanations. Some are volcanic, some are sedimentary, some are erosional. Some are uplifted and dissected remnants of larger surfaces. The causes differ, but the form returns. That is the point. Not that the world once held impossible trees, but that the same end state keeps emerging from different processes, and that our public vocabulary is too blunt to keep that distinction visible. The land is speaking in repeated shapes. We have been answering with administrative nouns, so the phrase survives, not because it is literally true, but because it notices something many official summaries pass over. Mountains do not all look the same. Yet a striking subset of the world's most memorable formations absolutely do. They look cut, they look crowned, they look exposed, they look like the remains of something larger. The science can explain why, the institutions can categorize what, the photographs preserve how. What remains is the gap between those three ways of seeing. And that gap is exactly where hidden histories thrive. Seen from far enough away, the argument compresses into a single unsettling reframing. The world is full of landforms the public calls mountains that are really the leftover anatomy of vanished surfaces, exposed cores, collapsed margins, and resistant caps. They resemble stumps because stumps are also the visible remains of subtraction. The analogy is wrong in substance and right in silhouette. That is why it refuses to die. The explanation changed. The shape did not. And the longer you sit with that, the stranger the archives become. The survey photographs, the feature names, the abrupt towers, the table summits carrying forests on top, the debris rings at the base, the repeated forms across continents, none of it proves a lost forest of stone giants. But it does prove something quieter, and, in its own way, more disturbing. Whole categories of landscape have been normalized so completely that most people no longer notice how improbable they look until someone gives the improbability a crude name. Then the eye cannot unsee it. Maybe that is where the real investigation begins, not in proving an impossible theory, but in asking why certain shapes keep slipping through explanation without ever fully losing their charge. Why some landforms feel resolved by chemistry and still unresolved by sight. Why the record contains the measurements, the maps, the cooling models, the erosion rates, the photographs, and yet the impression of truncation remains. The stone remembers. The record is still there. The pattern does not disappear. The real question is not whether the theory sounds strange, but whether anyone with the tools to verify it has seriously looked.